This is the chain rule. This is the chain rule. All right. So this is the last general rule. There are other specific rules, but this is the last general rule. So when I say general rule, I mean like the product rule, quotient rule, where it doesn't matter what the function is. So here, it doesn't matter what the function is, and you're going to have to apply the derivative rule. Now, here's the bad news. Oh, never mind. There's no bad news. All right. This is one of the most used rules. Okay, this happens a lot, especially on an AP test, mostly because it is very difficult to avoid composition of functions. Okay? All right. So, this author compares chain rule with those dolls that are like living inside of each other. Okay? When I was in college, the professor compared it to peeling an onion. Right? What you're going to do is you take one layer at a time. So you notice in the product rule and quotient rule, you might have two functions there, but you only take the derivative of one function at a time. That's an important concept, because in the chain rule, you're going to have more than one function, but you can only take the derivative one function at a time. All right. So this is the notation for it. So this is a composition of functions. So g of x is living inside of f of x here. And when we take the derivative, we take the derivative of f, keep the inside function, leave the inside function alone, but take the derivative and put it on the outside. So we don't do derivative outside, derivative inside. You're going to take derivative outside, keep the inside, and then take the derivative inside, but shove it outside. All right. So this one, the example here, this is not chain rule because this is not a composition. So you should know how to take the derivative of this function. What's the derivative of this function? 2x. That's it. So it's y prime equals 2x. That's it. All right. But this one, this is a composition of square root and x squared plus 1. So in fact, when I'm going to rewrite this, I'm going to rewrite it as x squared plus 1 to the 1/2. So my outside function is that exponent of 1/2, and my inside function is x squared plus 1. And let's go ahead and take the derivative real quick. So when I take the derivative, I take the derivative using the power rule on the outside. So it's 1/2, right? I'm bringing forward the 1/2. Keep the inside, and then subtract 1 from the exponent. So it's negative 1/2. But I'm not done yet. Now I'm going to take the derivative of the inside, which is 2x. And I'm going to multiply it on the outside. Questions?
No, that makes sense.
It makes sense, but I get it on that one, but I don't get the rule enough to do it. Does that make sense?
Yeah, you have a passive understanding
Yes.
and not a productive understanding. All right.
I don't think I've ever had a productive understanding.
No.
If you didn't, you wouldn't make the grade you're making.
Okay.
All right.
It means he's proud of us.
Okay, so this one is not a composition of functions, so you should be able to just take the derivative. What's the derivative sign? 4. All right. So this one is a composition of function, right? Be careful, don't rely on parentheses. So this is a inside function is 6x, the outside function is cosine. When I take the derivative of sine, which is the outside function, cosine, keep the inside times the derivative of the inside, which is just 6. Okay. I didn't do a rewrite on the first one, but I'm not comfortable leaving this one alone like this. Most of the time, it's very confusing if you leave something in the back or behind the function. I would always rewrite it like this. Like here, like we usually don't like to write parentheses for sine or cosine. To avoid writing parentheses, you can't leave that 6 back there. You got to move it to the front. Moving on. Ready?
3.
All right. Okay, this is not a composition. It's just 3x plus 2. So when I take the derivative, what's the derivative of that? 3. That's it. All right. And then over here, 3x plus 2 is living inside this exponent of 5. I don't need to do a rewrite here. I could just take the derivative. So derivative of the outside function is the exponent of 5. I bring it forward, keep the inside, subtract 1 from the exponent of 5, making it 4, and now take the derivative of the inside, which is 3. Let's do a rewrite for this because it's a very simple rewrite. I'm going to just multiply the 5 and the 3, making it 15 times, and then that.
So you would just like when you're bringing the exponent forward, you just treat whatever's in that parentheses like it was x.
Yeah.
Like you just wouldn't do it.
Exactly like that.
All of a sudden, I don't understand.
Congratulations.
Wait, I don't get why you did the fifth. Oh, you know.
I just did 5 times 3.
Yeah, I get it now.
All right.
Ah,
Yeah.
So this one, it's still not a composition because x is by itself and tangent x doesn't have anything inside. So when I take the derivative here, it's just 1 plus secant squared x. All right, now you got to be careful when we're taking the derivative. Never mind, not this one. I take it back. All right, this one's not that bad. All right. So let's take the derivative of this one. So the derivative of x still does not require chain rule, so it's just 1. But the derivative of tangent is secant squared. Keep the inside. So x squared gets kept. And now take the derivative of the inside, which is 2x.
Oh, 2x.
Did you say that's stupid?
So then when you put 2x out in parentheses.
Sure. So that'll be 1 plus 2x secant squared x squared.
Basically, there's not parentheses, imagine.
For a trig? Yeah, I would. Or just write it in. Alright, ready? We good? Alright, let's go on to the next one.
When are we going to use this? Like,
Wait,
what do we
but-
use this for?
Say what?
What do we use this for?
Taking derivatives.
That's it?
Yes.
Couldn't you?
It's like saying, you know, when do we use multiplication? You just use it. It's not a... So it's a skill like a lot of other skills. Now, when we get to chapter 3, I will show you what you're going to do with derivatives. Is
Because
that...
I was just saying, like, why couldn't we just use the shortcut? Like, why couldn't we do this?
Sometimes.
Oh! Okay, so how would you have taken a derivative of tangent x squared without this rule?
That'll do it.
Well,
makes sense.
that'll do it. That'll do it.
But
Alright.
you can use the quotient rule for this one.
Aha! Alright, so Amelia said you can use the quotient rule for this instead of having to do the chain rule. I think,
So I
chain
got
rule's
that on
easier.
recording.
huh?
You got that on recording?
Yes.
That'll do
Yes.
it.
Kaylee's gonna love looking over this.
Alright. Okay, so yes, and you're absolutely right. You can do this with the quotient rule, but let's see what it looks like with the chain rule. Alright? So when I do a rewrite, this is x plus 1 to the negative 1. Right? So remember, if it's in the denominator, I can just rewrite it with a negative exponent.
Oh, right.
And it's just 1 because there's no exponent.
Correct. Alright, so when I take the derivative, I'm using the chain rule. I'm using the chain rule.
This better be dog.
So bring the negative 1 forward, and then subtract 1 from the exponent, making it negative 2. And what's the derivative of x plus 1? 1, just plain 1. So I'm going to write the 1 for emphasis. Like if you didn't write it, that'll be okay, but I'm writing it for emphasis. Now let's simplify it. So I have negative 1. I'm just going to write negative 1 over x plus 1 squared. Alright, so Amelia, if I use the quotient rule, I bet I will be faster with the chain.
Oh.
Dang. Dang.
Wait, and why did you simplify it like that?
Because that's how you simplify.
How?
Because the negative 2, you keep it 2, and you just get rid of the negative by putting it in the denominator.
And, okay. Alright, that's it.
Alright.
That'll do it.
I'll do it.
I have no idea what they're talking about in the next one. Why would you rewrite sine 2x? So don't rewrite sine 2x and just use the chain rule. Alright? This is just like the second one of the second example.
Maybe they want you to put parentheses in it.
Oh, okay. Thank you. We'll go with that suggestion. Rewrite it so that it's obvious that it's a composition of function. So take the derivative. The derivative sign is cosine. Keep the inside times the derivative of the inside, which is 2,
This is 2 goes on 2x.
which is 2 cosine
Oh,
2x.
baby.
Oh, I think they meant to have sine squared x. Well, no, maybe not. Anyway, let's go on to the next one. So I'm doing a rewriting that square root as an exponent. Alright, now I apply the chain rule. So I take the derivative of the exponent first, the outside exponent of 1/2. So that'd be 1/2, copy the inside, subtract 1 from the exponent. Oh, I've run out of space, and the derivative of the inside is 6x minus 1. So this is that times 6x minus 1. And this doesn't really clean up very well. I'm going to write it really quick, and let's see if you follow what I did.
I follow.
Yeah.
No.
I follow everything except where you got the 2 from.
It's just
That
because
too.
the
Because it's
bottom part is not a straight
I
line.
don't
get
That 2 is there. It's a negative exponent, so I put it in the bottom.
Oh,
The exponent is 1/2, so I wrote it as a square root. 6x minus 1, the exponent on that is basically a positive 1. So that means it stays in the numerator. Okay? So a lot of these problems would be a lot less work if you just can follow the algebra. You're legitimately, you can do that in one step. And if you can do that in one step, no one's going to question. It's not one of those where you have to show every little step to get there. Ready?
Born ready.
You were born ready?
Oh yeah.
What does that even mean?
I was born ready.
She can do it 4.
Aha. Be careful.
Ooh.
Right? So the inside function is actually the tan. The outside function is the exponent of 2. So that's the rewrite whenever you see. So a lot of people get confused with this notation. I suggest you rewrite any kind of trig function with that exponent there like this.
Got it.
Now the outside function is the exponent of 2. So we do y prime equals 2 times tangent x to the first power. I'm writing the 1 for emphasis, okay? And then what's the derivative of tangent x?
Secant squared.
Secant squared x, very good. And if I were to clean this up, it doesn't really clean up well. I mean, it doesn't really clean up much at all. You just write it as 2 tan x secant squared x. So all I did was get rid of the parentheses.
Oh, what it is? For your coffee making me so hungry.
Same. Oh my god.
What's making you so hungry?
This class.
This class makes you hungry?
Yes.
I only eat in this
I
class.
only-
I'm like starving the second I
I have to say
It's one of my choices to find it.
I don't
I
even
eat
Elizabeth agrees.
Like Kaylee.
You hear that, Kaylee? Are you getting hungry as you're watching this video?
No, because she's probably eating
No,
something
Kaylee
good.
is. I guarantee you, Kaylee is munching on something right now.
She is. She definitely is.
100%. As she's watching this video, she's munching on something.
And she's laughing all
You never
over.
told
Yeah,
me.
because she knows we're right.
She didn't know
Gnawing
you
on
made
some
it.
cookies she just
Yeah,
made.
it's
I
so
guarantee you, she is gnawing on some cookies that she made.
Okay.
Well, I'm about to-
All right.
No.
This is, I don't know why this is a separate problem. Like you guys have seen this before.
Yeah.
Right? So dy dx, just apply the chain rule. You're going to bring the 3 forward, keep the inside, subtract 1 from the exponent, multiply by the derivative of the inside, so that's 2x. So that becomes 6x. Yeah, what you said. So, the point of that is, you don't have to, remember some of you were concerned that you'd have to actually learn how to expand a cubic? No, you don't have to. You just use chain rule.
What?
You can just use chain rule.
Yeah, just use chain rule. Don't multiply that out. Just use chain rule.
Okay.
Perfect.
Nice.
Right? That's why I didn't like emphasize you learning how to expand a cubic, because chain rule is just much easier.
What's going on?
So the
with
calculus was easier than the algebra. What's up?
What's happening over here with all these U's?
All right. So
Oh.
whenever they use the variable u, they're implying that u is some complicated function, right? So that's another way to write the chain rule. Okay. Now they talk about a general power rule, but I don't like talking about general power rule. Just use chain rule. Okay. General power rule is just chain rule for power rule. That's it. Okay. So let's just go on. I'm not going to worry about so much of this notation until we get to the ones where it's really needed. All right. So the first thing I'm going to do is rewrite this. So I have a cube root and a 2, an exponent of 2. So when I rewrite this, I'm going to write that as, I can't see it. So it's x squared minus 1 to the 2/3. Remember, when it's a radical, it is a denominator exponent, right? It's a new exponent that goes in the denominator. All right. Now do the chain rule. So that's going to be 2/3 x squared minus 1 to the negative 1/3, and then multiply by x squared is 2x.
4x over the cube root of x squared minus 1. 4x over.
Whoa. 3. Whoa.
Oh,
Wait,
skip
when
yeah. I
Take
forgot that.
that. For real. I didn't even know.
Okay, so we did 2 times 2x is a 4x. The 3 is in the denominator, so I leave it in the denominator. It's a negative exponent, so I put it in the denominator. That is a cube root, so it's 1/3 is the same as cube root.
Big brain.
Good job.
You're so sweet.
What do we get out?
That's good.
10:13.
All right.
Oh,
That's what the
We have 29 minutes.
No, I saw you post it. I commented
Alright.
immediately.
I was like,
Okay, moving on, moving on.
I was like, it has been 2 minutes.
Let's do a rewrite on this.
Has already gone.
It's -7, 2x minus 3 to the negative 2. So all I did was rewrite that positive exponent in the denominator as a negative exponent in the numerator. Now I do the calculus. So it's -7 times -2, which is 14. Keep the inside. Subtract 1 from the exponent. And then take the derivative of the inside, which is just 2.
Which would be 28. 2x minus 3. Negative
28
3.
over
Yeah, then
2x minus 3.
those are.
To the third.
Beautiful.
Okay, so all I did was 14 times 2, and it's a negative exponent. I bring it to the denominator as a positive exponent.
Yeah, we'll see.
Boom, baby.
I said I should.
All right, ready for C?
Oh boy.
All right, here we go.
That's pretty cool.
A pain in the
Okay,
um,
let's do a rewrite first. So, if you have doubts about what this means, like here you have that 3. Do you think that's a cube root or is that an x cubed?
That's
X
a cube
cubed.
root.
Oh, I don't
That's
know.
the cube root.
It looks like a cube.
No, that.
But it could be both.
no,
Wait,
X
no,
cubed,
no, it's a
because
part
if
of
you
the
look at
X,
the cube,
because
it's
look at
like
the top
sitting
one.
right
Look
above
at
the
A and how
little
close
check.
it is, like when it was
Yeah.
printed on A.
It's
It's
X
way
cubed.
too close.
Oh,
It's
yeah.
an X cube.
It's X
Exact
cubed.
same.
All right, okay, so we have decided that it's x cubed. That's fine.
Yes.
So when I rewrite this, it's going to be 5x cubed.
That was a stupid thing to do.
Wait, are you gonna do like a double check?
Wait. Actually, it doesn't make sense.
What?
It doesn't make sense to be a x cubed. Here's
But
the
it has
reason.
to be.
But it's
because
Listen,
it's
listen.
times 2.
If I take the square root of this squared, they just cancel each other out.
Yeah.
So it was meant to be a cube root.
Oh.
I'm so sad.
Or it could just
Or
be
it's
easy.
meant to be canceled out and make it.
It's highly unlikely to just be easy. No.
Well, but A.
What would we do
So it'd
on
be
the
3x
A?
plus
Yes.
1
Maybe
to the
they felt
2/3.
fine.
Wait, why'd you do that? I was
So
just
the
Okay,
one
if it were square root, then that 2 would just go away and it would just be.
What would we do on the AP test? Would we
Oh.
like be able to ask somebody what?
On the AP test, they will have better fonts,
Okay.
so it will not be as ambiguous.
I bought extra credit.
How's that work?
I did too.
Wow.
I think I already redeemed it.
This
Where do you guys get
Yeah.
points from? Oh, right, you guys are asking for it. So I take
I had
that
a
one.
bunch
Can we still do extra?
Yeah.
Okay.
Buy tomorrow.
By
Didn't
tomorrow.
you?
Well,
No, you didn't.
I'm a bird.
probably.
Oh, I still need to buy that paper. I'm gonna do that today. Oh, I have work today.
You should buy it on your way home or way to work. All right, let's take the derivative. Okay, so this is our first one where I'm mixing the rules. What rules am I mixing?
Product?
Product. So I have product rule and chain rule this time.
Why?
All right, because I have a product, it's 5x times that mess, and then chain rule because of this mess. Okay, so let's do product. So the most outside thing is the product. So I'm going to do, let's take the derivative of 5x, which is 5, copy the other function, plus 5x times the derivative of the other function.
Why couldn't,
Whoa. What are you doing?
Why couldn't you just do
I am doing product rule, right? Product rule says take the derivative of 1 and keep the other one. So that's what the 5 comes from. Took the derivative of 5x and I keep the other one.
Is it just 3
Plus
minus-
5x.
Yeah.
And now I got to take the derivative of this big mess.
Is it just 3 to the negative 1/3?
3 to the negative 1/3.
Or
You
2
mean
to
2
the
to the
negative
negative
1/3?
So, but I'm going to take all the steps, okay? So that's going to be 2/3. I'm bringing down the exponent times the function, 3x plus 1. Subtract 1 from the exponent, negative 1/3. Now, I got to take the derivative of the inside, so that's 3.
So you just
Wait a
do the
minute.
product rule until you get to where you have to do the derivative
Yes.
of that little function.
Exactly.
Wait, but you did. Why wouldn't it be 2/3 times 5? You just did 2/3.
You mean 2/3 times 5 instead of 2/3 times 5x?
No, because you had to take down the 2/3. Wait, okay. So for the 5 times 3x, that whole thing. Why
Right.
can't
I
you
only
just-
had, that's 5x is one function and this is the other function.
Yes.
So
why-
when the product rule, I only take the derivative of one function at a time. So there is no 2/3 here because I'm not taking the derivative of this yet. I'm taking the derivative of this part, of 3x plus 1 to the 2/3, over here.
Yeah, but why couldn't you do chain rule and do 5x times?
Because
2/3?
I'm in the middle of a product rule. You can't do both
No.
rules simultaneously.
Before product rule.
Okay, there is no before product rule.
The 5x.
You have to do the product rule first.
Oh, because you can't have an x there? Or why?
Well, this is not containing anything. The 5x is just 5x. This is, okay, so let's look at the functions here. So the functions I have is 5x and this function. You agree with that?
Yes.
So, and what's the operation between those two functions?
Multiplication.
Multiplication. So that is the outermost operation. And then within that operation I have chain rule. So I have to apply the outermost rule first.
Oh, I get what you're saying now.
Really?
Yes. Because, okay, yes, because it's 2. Because I was getting confused because in B, you could just go ahead and do the chain rule, but that's because it's not 5x, it's
You're right,
7.
it's just 7.
Can never know.
Okay, so cleaning this up, there's a bunch of ways to clean this up, and I'm going to run out of space. I'm going to just flip my paper over. And this one is a textbook favorite, and I'll explain why in a minute. All right, so let me cancel the 3's here. So I'm going to have 10x.
Wait, what 3's did you cancel?
The 3 down here and the 3 over here.
Why'd you do that?
Right, 3 in the denominator times 3 in the numerator to cancel. So I just have 3x plus 1 to the negative 1/3.
We just put it
Okay,
all
now.
bottom.
Hold on. I understand what you're saying, and I'm going to do that when I do it the second time. So I'm going to do this problem twice. Okay? All right, ready? Okay, now I'm going to copy this onto a blank piece of paper because I'm running out of space.
Me too.
Where is my, okay. So I currently have this 5 times 3x plus 1 to the 2/3 plus 10x 3x plus 1 to the negative 1/3. So all I'm doing right now is just copying what I have, okay? Alright, because I've run out of space and this gets really scary looking. Alright, now, let's step back a little bit. I think if you're, I'm okay with you just watching.
Okay,
Okay.
that's good. I like that.
Alright, I'm going to step back with a weird example before I do this harder one, okay? So I'm just going to go over here. If I have x squared plus, let's say 2x squared plus 3x, how do I factor that? Can I factor that?
That's a great question. People X out.
Pull an x out.
Oh, yeah.
You take an x out. So you get 2x plus 3, yeah?
Yeah.
Alright, the idea here is you just basically take out the lowest exponent. This is an exponent of 1. You take out the lowest one. What is the lowest exponent here?
Negative 1/3.
Negative 1/3. So I can take out 3x plus 1 to the negative 1/3.
So is it just 1x?
Hold on. So it's 3x plus 1 to the negative 1/3. Now, so the 5 is left alone. But what does it look like if I take 3x plus 1 to the negative 1/3 from that?
Wait,
Negative
say that again?
1/3.
Okay. Alright. So when I got here, when I took an x out, how did I get this one? This x. You subtracted the exponents. So what is 2/3
Oh.
minus negative 1/3?
1.
1. So it's 3x plus 1, period. Plus 10x. Let that sink in for a moment.
Wait, so you said.
Alright. So you understand that I'm taking out the lowest exponent.
Yes.
3x plus 1 to the negative 1/3. Now, when I take it out of this part,
Yes.
and remember over here, to take out that x, this is basically x to the 1, and I'm subtracting exponents, so it was 2 minus 1 gives me 1. So over here, I have 2/3 minus negative 1/3, right? Let's recall 2/3 minus negative 1/3,
That's plus.
that's
2/3.
plus, and so that's how I get 1. 2/3 plus 1/3 is 1.
So you just.
And then from here, I'm taking out that whole thing, 3x plus 1 to the negative 1/3. That leaves me to 10x.
And that's like the end of the.
Wait, why?
that's
That
it.
is not the end.
No,
Why'd
so
you
now
write the
you're
3x
right,
plus
yeah.
1 at the top?
Guys, you gotta do the thing underneath it.
3x plus 1 where?
Why'd you write the 3x plus 1 in parentheses at the beginning?
Good talk.
Because I am factoring it out. Right? Remember here, I took out an x. I am taking out this entire binomial. I'm taking out this cube root. That's what I'm factoring out.
Oh.
I took it out of both parts.
So then would it be that 5 thing in parentheses over?
Okay, slow down. Okay? So I'm going to take it in slower stages than you just did. Okay? So I'm keeping this as is for now. That's to the exponent of 1. So that means I can multiply it out. Right? So it's 15x plus 5 plus 10x. Okay, I'm still taking small steps. If you skipped any of these, that's fine. Combining my x's here, so it's 25x plus 5. Alright? Now, final step, 25x plus 5 over the cube root of 3x plus 1.
This is a little bit less.
Okay, I'm good after, like that first step, I'm so confused. I don't get like,
Well, let me try method 2 and see if you understand method 2 any better.
okay.
Damn.
Okay? There are 2 ways to look at this. Okay? That's one way. I like this way because I just think it's cool. However, the other way is probably the more normal way. Okay?
Can method 2 be interpreted as x cubed? I think it's
I have no idea. Alright. Ready? Method 2. So I'm going to copy what I have at the top.
Oh,
I can do
okay.
that.
Alright. I'm copying that. 5 times 3x plus 1 to the 2/3 plus 2x 3x plus 1.
So that one's back there.
Alright. Okay, so I'm starting from here again. So this is method 2. I'm starting from the first derivative. Alright. Now, so I'm going to do what Elena suggested at the beginning. Or she said there's something like this. Alright. So I'm rewriting it with the exponent becoming positive. So I'm going to rewrite that as 10x over 3x plus 1 to the positive 1/3. Okay? Now, so this is one of those multiple choice questions. They're probably going to clean up to this. Okay? Alright. What is the common denominator here? Well, there's only one denominator, right? So it's just this. Okay? So that means I'm going to write that as a denominator over here, and nothing changes in the second fraction. But if I write 1/3, the 3x plus 1 to the 1/3 on this one, what happens to the numerator? I have to multiply by that. So that's 2/3 plus 1/3. So it's still 3x plus 1 to the first power.
2/3 times 1/3?
It's 2/3 plus 1/3.
Oh.
Emilia,
Mm-hmm.
you get that?
Yes.
Alright. Now, distribute and combine. So 5 times 3 is 15x plus 5 plus 10x over the common denominator 3x plus 1 to the 1/3.
That's not a good time
I
to
think
watch
I'd
that.
rather go with your option. But I had the right idea.
So combine the x's and you get 25x plus 5 over the cube root of 3x plus 5. Okay? That was method 2.
I don't like either of them. I have a question. Why
Yeah.
can't you go from, okay, the beginning thing we started with.
Uh-huh.
Why can't you go from 5 times 3x plus 1 to the 2/3 to drop the 2/3 over the 5 and do
Drop the
chain rule?
2/3 over the
So like
5.
multiply 2/3 times 5.
Wait. Okay. So you mean you're going back to the original problem?
I don't know what it is.
Because now you're confusing algebra with the calculus. Right? So now you're telling me to do something with the 2/3 with the 5, but that's calculus part. This was algebra.
Oh, so after you've done the power, after you've done the
Right, so from here to here is just algebra. This is not calculus.
Wait,
So there is no messing with the 2/3. There's no bringing down the 2/3.
So you can't then find the derivative of that again.
You could, but they're not asking me to find a second derivative. Right? Finding a derivative is not simplifying. You understand what I'm saying?
Yeah, so as soon as you're done with the... Okay, wait. You go to
So, if this were a free response question and all they wanted was the derivative, I could stop there because that is the derivative. Okay? If it were, now notice I said free response question, but if it's a multiple choice question, I might have to clean that up through algebra. And notice both versions ended up with this as the cleanup.
Okay, so my issue isn't the finding the derivative, it's just the algebra.
It's the algebra. And by the way, in calculus, algebra is what students have the most difficulty with. And luckily, the AP test tries to test you on your calculus more than your algebra. Yes, sir.
Can I use this?
Yes.
Do I get S?
Yes. All right. Ready for example D?
Oh, that was just C, wasn't it? Yeah.
Corn ready.
It could have been avoided if we just interpreted it as x cubed.
Honestly.
I think that would have been harder.
No, that would have been easier.
Really?
Yeah.
We would have done what?
Because we would have done the algebra instead of the chain rule.
If,
All right. So, D,
Oh, yeah.
what rule comes to mind for D?
Quotient.
Quotient rule.
That's
I love
Because you not make it like to the negative
half and
Then it'll be a product rule. Do you want to switch it to product rule?
No,
instead
which
of-
is easier.
no.
I don't know.
I
Because
hate the
then we,
exponents that are fraction.
but then we got the denominator work with.
Okay, in this problem, I don't think either one's better than the other because of the square root.
I
Okay.
would say that we do negative a half.
That's easier because then we don't have a. Well, I mean, we eventually will have a denominator to work with, but I don't like working with it.
Okay, anybody else have an opinion? Well,
We haven't learned how to do quotient rule though.
let me say this. I think we just need to practice with the quotient rule.
Okay, I agree.
All right. But you're right. You could.
It's just easier for my brain to not work with the denominator until the very end.
Me personally, I'm gonna change it, but that's just
Right. I mean, that's okay. As long as you realize what you need to change algebraically, that's fine. Just the weird part is, what if there's a trig function down there, and you rewrote it using?
And you know what? We'll figure it out. The Kaylee method will have to
Well,
work.
Kaylee method are with you.
All right, here we go. So I'm using the quotient rule. Well, first I'm going to rewrite it as x squared minus 3 to the 1/2. Now I use the quotient rule. So g prime of x. I bring the denominator up. Times the derivative of the numerator, which is
I thought for the
2x.
question rule, you take the derivative of the numerator first.
I did, 2x.
See, you do it differently than me. You like just write it differently. It confuses me.
They do it backwards.
Because I just say, like, the only reason I know how to do it is I say derivative of the top first. And then I put that first.
Oh.
I just bring it up and then do the derivative.
Well, so no matter which way I do it, I confuse somebody.
Yeah.
Loady high, high low. That's what I.
All right. So see, that's low-d high.
Well, mine.
You're in the minority. All right.
I
Well,
am
Kaylee
ginger.
and Annie do it that way too.
Okay.
It makes more
Are you?
sense. A ginger? Yes.
Do you dye your hair?
Yes. We're trying to get rid of it. I'm in denial.
I would have never guessed.
You got your hair
It's
blonde?
very, yes.
Guys, don't hype me up right now.
I don't know what they're talking about. All right.
I'm a ginger, but I dyed my hair so you can't really tell anymore. Which is the point.
You should embrace it.
That's what I'm saying.
I'm with
No.
that.
Yes,
You don't like
It's
it?
not the
We've
typical
literally
ginger.
known each other
It's
for
like
like
I know, but,
strawberry
like-
blonde.
4
It's
years.
not
You
like,
did in 8th grade.
it's not
Like-
like red.
In my defense, I met
It's
you
like
this
a-
year.
I mean, it is, but it's like a strawberry.
It was orange.
It's
So I
orange.
got rid of it.
It was.
Whoa.
I remember that.
And you know what? I probably wouldn't have got rid of it if y'all didn't make fun of me. So it's your fault.
You just did chain rule too, right?
Yeah.
I don't like this. I've decided.
Very much.
Fine.
Whoa, I'm
Makes
doing
my
it
head
right.
hurt.
I'm doing it right. Whoa. Maybe not. Just kidding. Where'd the 2x come from?
Derivative of x squared minus 3.
I did that very well.
I don't like it.
So it's quotient rule till about here.
Can we just like take out some of the
I don't know what it is.
parentheses?
Parentheses.
There are these 2 doors at USGA in the building that I'm in, and the freaking door handles go like this. They're like C's. And you would think if like a door handle's like this, it like literally goes like this, that you would stick your hand in it and there's like a hole. No. It's solid. You have to grab the top. And I literally stood there for 5 minutes the other day. Like I've been going there for like 3 straight months now, or however long we've been in school. I never knew how to open the door. And there was a line of people waiting behind me to get in, but I couldn't open it.
That's embarrassing.
And then when I finally did open it, I dropped the door, so it just shut again. And Lauren finally had to just open the door because I couldn't do it.
Wow.
I thought I should share.
Thank you.
Thank you.
All right, let's clean this up. So not much happening there.
That'll
2x
do it. That'll do it.
x squared minus 3 to the half. I've got that 1/2 and the 2 cancels. And I got x times x squared, making it x cubed. And I've got x squared minus 3 to the negative 1/2.
I'm sorry, where'd you get x cubed?
Wait, that's x cubed?
I have, yeah, it's x cubed. I have an x squared here, right?
Yep.
From that. And then the derivative of the inside was 2x. So x squared times x is x cubed.
But then you gotta put the 2.
The 2
Oh.
and the 1/2 cancels.
Oh.
Or
You just gotta
reduces.
split it up.
Huh?
You just split
X
it.
squared minus 3. Oh.
Me personally, I hate this.
Me personally, I feel like I don't want to do that.
Me personally, I would have
Alright.
Yeah.
Okay. Okay, I'm running out of space, so I'm using more blank paper.
Wait,
I'm gonna just.
never mind.
Alright, I'm copying this over. So right now I have g prime of x equals 2x
I'll take it. I'll take it.
x squared minus 3 to the half minus x cubed x squared minus 3 to the negative half over x squared minus 3. So there was no question of how I got x squared minus 3?
No.
No.
No, because you square it, and then it eliminates the 1/2.
I'm just not even paying attention, but yeah, probably.
No, I questioned it, but then I
But
checked it,
yeah,
and then I was like, that makes
That's
sense.
why I just said wait, and then I realized.
I feel light.
Okay, now I gotta clean this up.
But if it's the response, it could this could be the answer.
Correct.
This is the derivative,
What?
so I don't need to be doing any other
Oh,
derivatives.
yeah, and you.
Correct.
And this is what's
But you could use the algebra practice. Huh?
Just,
so I can make sure. How did you get the
I
product?
thought you said that.
Alright, so remember with the quotient rule, you take the denominator, which was 1/2, right?
Square it.
And square it. So the 2.5 cancels. And leaving you 1 or whatever. Alright, now I'm going to factor out x squared minus 3 to the negative 1/2.
That's what I meant by the.
Why? Why do you
When I
choose
started
that to
talking
do?
about the doors.
Because the common factor, I always take the lower exponent.
Oh.
Right? I'm also going to take out an x. Yeah?
They're like this, and I can't open
Can I
it.
take out an x too?
Yeah.
Yeah.
Alright. So that's going to be x times x squared minus 3 to the negative 1/2. And then here, that's going to leave me 2 times what?
Why'd you take an X out, but then you didn't take an X out?
I did take an x out. I'm not leaving that x there.
That's 2 times.
It's 2 times that, right?
1.
Which is x squared minus 3 to the 1.
Wait,
He took the x out of the
You
2.
got.
Wouldn't it be
I don't know where the
negative
2
one?
went.
Wouldn't it be
It didn't go anywhere. It's right there.
Wouldn't it be
Which 2 are you
negative?
talking about?
yeah, I believe it's negative.
Well, let me finish it. Maybe it'll make sense.
Yeah.
So it'll be minus x squared.
Oh my.
Wouldn't it be negative 1?
What's negative 1?
When,
The exponent on
Yeah.
the second
On this one?
squared Yeah.
yeah.
It's 1/2 minus negative 1/2.
Yes.
So it's not.
I hate that.
By the way, this is only algebra. This step is only algebra. This is not a calculus
Yeah, I
step.
don't get any of that.
Alright, so there's an x in common.
Yes.
So I took an x out, so there's no
in
x
common-
here.
Wait, X in common with what?
Alright, there's an x here and an x here.
Yes.
So
But
I
they
took
don't have
it.
the same exponent.
Alright, let me do some algebra down here.
Well,
Oh.
if you have
If I have 3x squared plus 2x, what? I have an x in common.
Yeah, but I'm saying the
So that's
negative
3x plus 2. I just take one out at a time.
1/2. Yeah, but the negative 1/2.
But I'm only dealing with the x outside the exponent of half and negative 1/2. I'm only dealing with the x and x cubed, not the x squared inside.
Okay, so where did the X?
Okay, so now let me explain this part. The x squared minus 3.
Yeah.
Alright, so whenever I took x squared minus 3 to the negative 1/2 out, I am subtracting the exponent. So it's 1/2 minus negative 1/2, which is to the first power. So it's to the 1. But when I took x squared minus 3 to the negative 1/2 out of this part, it's gone. And I just have x squared because I took an x out of that as well.
do I get this stuff, but I don't get literally any, like, the other stuff that everyone else gets?
Because this is algebra.
This is algebra.
I'm bad at algebra.
I'm gonna pretend I understand.
So
and you're
then
just gonna keep
You
it.
put that little x squared minus 3 in the denominator. No, not that one, the other one.
The first x squared minus 3x, whatever.
Alright, so when I put that in the denominator,
But square root it.
it becomes x squared minus 3 to the 3 halves.
Whoa. Wow.
Okay, let me take another step. So x squared minus 3, x squared minus, that's the same x squared minus 3, okay? And if I bring that downstairs, that becomes x squared minus 3 to the positive 1 half, yeah?
Oh.
Then it's like 2 over 2 plus 1 over 2. So it's 2
Right.
over 2.
That's where 3 halves comes from. So this is 1 plus a half is 3 halves.
Like crazy movie.
Could you not do x squared minus 3 times square root of x squared minus 3?
Okay, so
Would
she's
that not
saying
be the
this,
same thing?
x squared minus 3 times the square root of x squared minus 3.
Yeah.
Teachers, at this time, we will begin our earthquake procedures. Please make sure students are on the floor.
That's the end of class.
Students